Today we're going to be talking about section 19.2, present value, the big picture. Here's an example of present value. So this is an example of how much money it would take to put into an account at the present value to end up with $1 in future value. This one happens to be 8% for periods, so compounded annually or whatever would happen there. So you would need to start out with 73.5 cents, and then that would grow to $1 in that length of time. What we're going to do here is something similar to that. We'll know the future value. We were going to come up with our present value to see how much money we would need at that point in time. This is another example of that. We used this example in the last video, the last section in 19.1 about if we had $80 as present value, it would grow to 108.84 future value. And so we can see that's how much we would, if we knew the future value, we could calculate the present value of $80. So on this one, if you were going to put this in your calculator, this is, by the way, compounded annually. Here's what you would put on your calculator. So it's compounded annually for 4 years, right? This is 4 years. So you would put a 4 in for N. It's at 8% interest. And since it's annual, we put the full 8% in. You put 108.84 and press future value. That we do put that in as a positive because future value is always positive. There is no payment, so you would put in a 0. And then you would compute present value. And that's where you would come up with this $80. Now you'll notice that on your calculator it will have a negative on that, and so that's because that's an amount that you're putting in. Something I've noticed with the book sometimes is they don't always list something with the negative, and so that'll be something to kind of be on the lookout for. So here is an example for us. Yes, and I have a reminder to clear your TVM keys because that just helps you keep your calculator from getting too jumbled up so that it will calculate correctly. If you're finding that you're getting answers and they're not what they should be, then you might want to reset it even, and that can help. So Paul promised his grandson Jamie that he would give him $8,000 7 years from today. So $8,000 is our future value. Okay, 7 years from today for graduating from high school. Assume money is worth 6% interest compounded semi-annually. This means that we'll take our 6% and divide it by 2. So our interest rate is 3%. What is the present value of this $8,000? So we wanted to end up at $8,000 6 years from now. We are not paying a payment. It is compounded semi-annually for 7 years. So 7 times 2 means we have 14 periods for this. We're going to compute the present value. So the amount of money that would need to be invested would be $5,288.94. And we put that as a negative because that would be going into the bank to earn interest and grow to $8,000. One thing I might point out is present value is always a smaller number than future value. And future value is always larger than present value. Okay, so on this question I'm going to show this 2 ways. I thought this was interesting, and that's the reason why I wanted to show you both ways. Pete Ayer wants to buy a used Jeep in 5 years. He estimates the Jeep will cost him $15,000. Assume Pete invests $10,000 now at 10% interest compounded semi-annually. Will Pete have enough money to buy his Jeep at the end of 5 years? So we're going to show this both ways. We know the present value that he has. We know the future value that he needs. So on the first one, we're going to compute present value. That means we're going to put in our future value that he needs of $15,000. It's going to be at the end of 5 years. It's compounded semi-annually. So 5 years times 2, we'd have a period. Our period's 10 periods. The interest rate is 10%, and we're dividing that by 2. So 5% interest per period, no payment. And then we compute our present value. So when you compute your present value, you get $9,208.70, which is less than the $10,000. So it looks to me like it's going to work out because he only needs to put in this much, $9,208.70, to end up with $15,000, and he has $10,000 to invest. Let's double check that. I'm going to say this, that's less than $10,000. Now on this one, we can leave this the same, this the same, because the interest rate is the same. We can leave the payment the same. So that means the arrow is saying same numbers as above. We don't have to change those. But now we're going to put in, we're investing $10,000, and we're going to see how much that grows to. So this time we compute future value. Okay, so change your present value to negative 10,000 and then compute future value, and you should get $16,288.95, which tells me for sure that yes, he's going to end up with this $15,000, right? Because that's more than $15,000, and that's what he was trying to end up with. So the answer to those questions, will Pete have enough money to buy his Jeep at the end of 5 years, is yes. Okay, next example. Giselle wants to visit her family in Zimbabwe in 2022, which is 6 years from now. Well, not from right now, but in the book, that's what it was. She knows that it will cost approximately $7,500, including flight costs, on-the-ground costs, and extra spending money to stay for 4 months. That's a pretty extended stay. If she opens an account that compounds interest at 5% semi-annually, how much will she need to deposit today to cover the total cost of her visit? Okay, so 6 years after this, let's not worry about the fact that 2022 is really just around the corner. How much does she need to deposit today? So we are going to compute present value. And let's fill out everything else. So we know we need to end up with $7,500 for future value. Now you know you can go ahead and put this on your calculator. Be sure and clear your CVM keys. You can put the $7,500 in first. Our payment is going to be 0 again. It is 6 years compounded semi-annually, so we're going to multiply 6 by 2. So we have 12 periods. It's 5% compounded twice a year, so it will be 2.5%, the number we put on our calculator. And then we will compute our present value. So the present value amount that would need to be on deposit would be $5,576.75. $0.67. And then in that 6 years time, it would grow to $7,500. Okay. Here's the next question. Earl wants to retire in San Diego when he is 65 years old. Earl is now 50. Okay, so right off the bat, we see that in 15 years, he wants to retire. He believes he will need $325,000 to retire comfortably. To date, Earl has set aside no retirement money. Assume Earl gets 6% interest compounded quarterly. How much must Earl invest today to meet his $325,000 goal? So that means that we're computing future value again. And then let's fill in everything that we need here to come up with this. His future value, it needs to be $325,000. He is not paying any payments. By the way, we're going to get to having some payments in chapter 20, so we will not always be putting zero there. He's going to accumulate this for 15 years, compounded quarterly. So that means 60 periods for the length of this time. We're going to take 6% and divide it by 4. So 1.5% on the interest per period, right? So each quarter it compounds at 1.5%. And then we're going to compute the present value. Now you can imagine this is a pretty good chunk of money for it to grow to this amount in those 15 years. So go ahead and push compute present value. Pause this, remember, so that you can get everything on your calculator and try this yourself. Because it's all about learning how to use your calculator this way. And I feel like this is the kind of information we all need to know, right? This is interesting information. Okay, so he would need to deposit $133,021.19 to end up with $325,000 in the end. Now, I do think this is kind of interesting. If you calculate how much interest he earned, we would just subtract the present value. And so interest earned would be a nice little chunk of $191,978.81. And that's a lot of interest, you guys, right? That's a lot of interest. So anyway, that's the end of this problem. I'm going to stop this video and we'll have a second video to finish the lesson.